GIS 105, Elements of Photogrammetry, Lecture 4, in which we discuss cameras and collection devices. We said earlier in our definition that photogrammetry was about using light to measure and draw. Using light, in particular, we're talking about capturing light, and specifically that means photography. In this video we're going to talk especially about aerial photography. We need to make that distinction because it is possible to use photogrammetry in other contexts. One would be what's known as close range or terrestrial photogrammetry, that being taken from cameras that are ground-based. I guess I should say not aerial or like small format cameras up close. I have seen close range photogrammetry used by NASA, camera attached to the robot arm and taking pictures of the tiles to measure any kind of aberrations there. Close range is small format, up close, or ground-based. Photogrammetry can also be used in medical settings for x-rays, but as I said, in this section we're going to talk specifically about aerial photography. When we are taking aerial photographs, there are a couple of goals that have to be accomplished in order to use them for the photogrammetric purposes. First of all, it has to be measurable photography. By that I mean that the angles and distances in the photograph have to accurately reproduce what happens in real life in very, very accurate forms. And we'll see how that's done. That has to do primarily with the camera. We have to take measurable photography of the target area and at the proper scale, and this is going to get into the job constraints, flight planning. This will be towards the end of the quarter as we start to talk about especially the making sure we got the target area covered properly. Scale will be a little bit sooner, and we also need to make sure that we have 3D capabilities from the photography as we continue to define and refine our ideas of what photogrammetry actually is. We'll see that everything is going to be done in 3D. All the measurements are going to be done that way. And so we need to make sure that we have measurable photography of the target area at the proper scale and with the capabilities to measure in 3D. The camera systems themselves, and in particular the film-based camera systems, are classified into one of three classifications. Something dealing specifically with the angular field of view. Before we do that though, let me explain this illustration because we're going to see a lot of illustrations like this, similar from different angles, different labeling. But what we've got here is the inside of a camera, broken down to the most basic units. That yellow shaded area is the film itself, or where the image is being collected. So that is the photograph. That upside down pyramid, that represents light coming through the lens, at the back of the lens, the rear nodal point. If you want a good definition of what the rear nodal point is, you can check out that link. But in essence, all the light comes into the camera from different angles. It passes into the lens and then passes out of the lens behind it and then strikes the film. The place where the film or the light emerges from the lens at the same angle that it entered from the front is called the rear nodal point. Um, if we were talking about that object space and the image space from the previous lecture, the image space is all reduced down to that pyramid from the nodal point back to the film. Uh, the dashed line labeled F, that is the axis, the optical axis of the camera. F is the focal length. Focal length is the distance from the rear nodal point to the film plane. The D is the diagonal distance across the imaging area. So the angular field of view measures the angle that is formed from the rear nodal point to the extents of the photography. Anything less than 75 degrees is considered normal, a normal view. Aerial systems really don't deal with telescopic. I'm sure if you were talking about a regular camera, there's a place where there's an angle where things become telescopic. Wide angle is anything from 75 to 100 degrees, and then greater than 100 degrees is super wide angle. Just to give you some frame of reference, if you've ever dealt with a typical 35 millimeter single lens reflex camera, you know, the focusing, manual focus on the front, and typically those are going to come with a 50 to 55 millimeter lens. Just as a reference, depending on the focal length, that angle of view is going to be somewhere between 50 and 60 degrees. To get into a wide angle lens on a 35 millimeter camera, you'd have to be about a 37 millimeter lens would give you about a 75 degree angle of view, and then as the lens gets shorter, the angle of view would get higher. Those are the classifications of aerial cameras. Most normal mapping applications are going to use a wide angle lens, and we'll be able to compute that later given the measurements of an actual camera. Speaking of the camera, there are a few things that distinguish an aerial camera as being different than probably anything that you've ever seen in a photographic setting. One thing is going to be the size. Everything that I am going to describe here, the camera itself is about the size of a small file cabinet. If you can picture a small 2-drawer file cabinet, it weighs a couple hundred pounds. In order to get it out of the airplane and carry it around, it takes multiple boxes and a couple of people to pick up most of the parts. So it's a fairly good size. There are several parts. One being the magazine. The magazine is what you're going to carry the film around in. It's really the only thing that typically leaves the plane in most normal situations. You load the film, take it out to the airplane, and attach the magazine to the camera itself. So primarily that's just a way to cover and contain the film. Next is going to be the camera body. The magazine in the illustration is the purple section. The body is going to be kind of the brown, and the bottom part of the purple, where the separation is made is kind of subjective depending on the camera, how the camera is made. The camera body is usually a very rigid one-piece casting. It's going to contain all the important electronics, the important controls, everything that's going to drive the film. Of course, it's going to interface with the magazine to make sure that the film can be transported. But the film drive mechanism works in a pattern. You expose the photograph, you release the film, you transport the film, you flatten the film, and then you do the whole thing over again. The film flattening, whether it's a combination of the magazine, the camera body, and the platen. The platen is the dark blue, and that's what the film is flattened against. Usually it's some sort of a vacuum system. You can't have a pressure glass in front because then you'd be introducing optical problems. But it's usually some sort of a vacuum that pulls the film flat against the platen. Uh, very, very flat surface. The, 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 the tolerances on the platen are just microscopic. FMC is called forward motion compensation because, of course, the airplane is moving. Some cameras have forward motion compensation where they will move the film just tiny amounts at the time of exposure to compensate for the fact that the plane is moving forward and the camera is actually moving. Rather than trying to take a photograph with a still photo of somebody running in front, here it's the camera that's actually moving, but it can be compensated for. All the power and motors are also going to be inside the camera body. The lens assembly in a typical camera is going to be about the size of a basketball. A few things about it. Inside the lens assembly, you're going to have the lens elements, the glass, the shutter and diaphragm. The shutter is what keeps the light out. The diaphragm is the hole that the light travels through. Shutter is going to control how long the photograph is exposed with the shutter speed. The diaphragm is going to control the f-stop by varying the size of the hole. The lens assembly is all encompassed in a what's called an inner lens cone. This is be made out of something that has very, very low amounts of thermal expansion or contraction, because the temperature is going to change, the pressure is going to change, and the lens, the inner cone, is going to account for all of that. There's going to be a filter that is going to account for things like reducing haze, uniformly distributing light, protecting the lens, and usually for black and white, we mentioned before, for black and white photography, a yellow filter is going to be used to cut down on the haze, to cut down on some of that refracted blue light. So that is the what a typical aerial photogrammetric camera is comprised of.